Okay, so let's talk about harder general trinomial factoring. And I just want to do a quick review here. So we started by factoring easy general trinomials. So we had something, and again, our pattern when we realized that we needed to know how to factor them was we started to say, well, how do we even get them? If we start with two binomials that are going to create an easy general trinomial, how will we get that trinomial? So we noticed this pattern that if we have x squared, then minus 2x plus 7x minus 14. We combine like terms, we get x squared plus 5x minus 14. We notice that this term came from the product of these two, and this term came from the sum of those two. All right, so then we would say to ourselves, all right, I'm looking for two things that multiply to 14, 1 and 14, or 2 and 7, but then they must subtract to equal 5, right? And so we noted the subtraction part came from, if I get a negative 14 from these two things, one had to be positive, one negative, and when we have one positive integer and one negative integer, and we're adding them, we actually end up subtracting. So we would subtract those two numbers to get 5, and the larger had to be positive. Then we started looking at what happens if I want to make a harder general trinomial. So if I have something like 3x minus 1 times 2x plus 5, that will necessarily make a harder general trinomial because I have coefficients that are different from 1. All right. The way we got this x squared here in the easy general trinomial was we had two variables that had coefficients of 1. So as soon as I have something other than 1, we're going to end up with a harder general trinomial. So we multiply it out just to see what it takes to make it. So we get 3x times 2x, and then 3x times 5, and then negative 1 times 2x, and then negative 1 times 5. And when we combine them, we get 6x squared, which we notice just comes from the product of the first two, right? 3 times 2 gives us 6, x times x gives us x squared. These middle terms, we'll think about this in just a second, but this is 15x, and this is minus 2x, and then we get minus 5. Again, this constant term comes from doing the product of the two constants, right? But these middle two terms, we realized, and when we combine them, we get 6x squared plus 13x minus 5 did not come from two things that multiplied together to give us 5, right? There's no way we could get 13 out of that. It actually requires us to consider the effect that this 3 and the 2 have in creating that. Again, it wasn't just a 5 and a negative 1 that went into making this. It also took into account the factors of the 3 of the 6, which were in our case a 3 and a 2. All right. So what we end up saying here is very similar to what we say in this easy general trinomial situation. Again, we're looking for two things that multiply to something that add to something else, but we have to take into account the effect that the 6 plays on it. So we're not going to say anymore, I'm looking for two things that multiply to negative 5. I'm going to say I'm looking for two things that multiply to the product of 6 and 5. All right. So two things that multiply to give us 30, and then from there I say the same thing. I want them to subtract to 13. All right, again, we'll play with the signs in a little bit to work it out, but for right now I'm just going to say two things that multiply to 30 that subtract to 13. So let's think about things that multiply to 30. 1 and 30, 2 and 15, 3 and 10. Actually, we don't need to keep going because this is it right here. 15 minus 2 is going to give us that 13 that we're looking for. All right. So again, it doesn't, the 15 and 2 aren't going to give us the 5 like they did in the last problem, but it's all going to work out here. All right. So then from here, what we do is we turn this into a grouping problem. And so I'm going to continue this rainbow looking arc here. So I want you to move these things out to the side. So we're going to have 6x squared and then minus 5. All right, so these two terms just come right down. And then I need to rewrite plus 13, positive 13, as a combination of these two, right? So in order for me, excuse me, to get positive 13 through subtraction of these two numbers, I'm going to have the 15 be the positive and the 2 be the negative. Right? And again, as I go back up here and I look, I need to make sure that when I combine these two, I get exactly this. Sometimes what you'll do is you'll put the signs in the wrong spot and then you'll get the opposite of this. So make sure each time you do it, you check to see that you actually did the right arrangement of the signs. Okay, once we have that, we're going to group. So I'm going to put these two together. Again, the sign between the second and third is negative, so I need to make sure that I change this to a plus, a negative, so I can group that in the parentheses right here. Now I'm going to go through and I'm going to take out the common factor. So in the first two terms here in the first grouping, I notice that they both have a 3x in common. When I take that out, I'm left with a 2x plus 5. Right, these two have nothing in common. 2 and 5 are both prime, but because this is a negative, I'm going to take out a negative version of whatever I would have taken out. I would normally have taken out a 1 since they have nothing in common, but now I'm going to take out a negative 1. Right, when I divide 2x by negative 1, I get positive 2x. When I divide negative 5 by negative 1, I get positive 5. Now that I have these two identical, and again, this is a spot that you could mess up because of that negative sign, so make sure you take it out of both parts, otherwise you're going to get your signs all messed up here. Now that I see that I have identical factors here, two common things, one in each term, I'm going to remove it. So 2x plus 5 gets taken out, and then I say what's left over. So if I take 2x plus 5 out of the first term, what's left is a 3x. And if I take a 2x out of the second, 2x plus 5 out of the second term, what's left is a minus 1. And that is exactly what we had when we started. Right? So this is the process that we go through to do harder general trinomial factoring. All right? We take into account that we need both the leading coefficient and the constant to come up with that target number. And then we say the factors of that target number that are either going to be added or subtracted depending on the sign to make this, and then we form a grouping problem. All right, so let's try some just to get you more practice with them. So this should be the sheet that I sent to you through my school, and I want to try some of these with you. We're going to skip the first, we're going to skip this one because, again, I just want us to practice harder general trinomials. So these are all things that you can already factor because they're easy general trinomials. We're also going to skip this one because, while it's worth doing, it's not a trinomial. So I just want to focus on the harder general trinomial problems. All right, so let's take a look at number 5. We'll stick to the odds. In number 5, hopefully you can see that this is a harder general trinomial. It's a trinomial. The pattern of the exponents is that general form where the highest exponent is double whatever this one is, and there's no variable right here. And it's harder because of the 7. All right, so we're going to do what we did before, and we're going to say, I'm looking for two things that multiply to 7 times 20. Right, 7 times 20 is 140. This is a perfect place to have your little calculator right next to you, just so that you can make sure that you don't mess up on that part. I don't mind if you use a calculator to find the factors. Sometimes people multiply to the wrong thing and then they get the wrong factorization, so make sure that you do that properly. I tend to go in order until I find what I'm looking for. I know some people just randomly do that, but I feel like it helps me find all of them. So I'm going to start with 1 and 140. 2 and 70. And again, I'm looking for two things that multiply to 140 that subtract to 31. Right, sorry, I don't think I said that. Two things that multiply to 140 that subtract to 31. So that is times 2 and 70. 3 does not go into it because if I add the digits, I get 5, and 3 doesn't go into 5. 4 does go into it because 4 goes into the last two digits. So 4 goes into that 35 times. 5 will go into it 28 times. Again, I'm looking for things that subtract to 31, and I just passed it. It's right here. All right, so now I continue my rainbow down here, and I put the 7x squared and the minus 20, and now I need to combine these two through subtraction to get negative 31. It does not matter which order you put them in. So if you decide to put the 4 here and the 35 here, or the 35 here and the 4 here, it won't make a difference. So in the last example I did, I put the larger one right here and then the smaller one. So let's do it the other way around, where I put the 4x and the 35x. Let me just put this a little closer though. Right, now I have to play with the signs. I need these two to combine to negative 31. That's got to mean that this is a negative 35 and this is a positive 4. Right, there's no other way I can combine them to get that. Right, now I start grouping. I'm going to group these two together. And again, because I have a negative sign between, or subtraction sign between the second and third terms, I have to change this to plus a negative 35. Right, hopefully you write a little bit bigger so that it can, or maybe a little smaller, I guess, so that you have more room here. I'm going to take an x out of here. That's going to leave me with a 7x plus 4. And I'm going to take a negative out of here, first of all, because of that sign. But then the common thing that they share is a 5, so I'll take out a negative 5. When I take a negative 5 out of 35 and I divide that out, I get a 7x. And then when I divide a negative 20 by a negative 5, I get plus 4. Now I see that both terms have a 7x plus 4 in common. So I'm going to take that out. What's remaining is the x from here and the 5 from here. So this should be our factorization. Again, you should never get these wrong, because you can always check to make sure that you, when you multiply this out, you get the exact same thing as we started with. So for this one, let's just do that. The others, just for time's sake, I won't. But for this, it would be 7x times x is 7x squared. 7x times negative 5 is negative 35x. 4 times x is 4x. And 4 times negative 5 is negative 20. I combine these two, I get 7x squared minus 31x minus 20, which is what we had. Okay, let's try the next one. Again, I'm looking at a harder general trinomial. I'm also, and I didn't say it on the last one, I'm also looking to see if there are any common factors in here, if we can do GCF factoring. I see this and this both share a 7, but this does not, so they have nothing in common. So I'm looking for two things that multiply together, and again, your calculator is going to be a big help here. 7 times 20 is 196. All right, so I need to write the factors of 196, and I'm going to stop when I get to the pair that subtracts to 45. All right, so 1 and 196, 2 and 98. 3 does not go into it because 6 and 1 is 7 and 9 is 16, which is not divisible by 3. 4 does go into it because it goes into 96. So 4 goes into that 49 times, and that is it. All right, 49 minus 4 gives me that 45 I'm looking for. I'm going to make my rainbow a little bit bigger this time so I have more room. All right, so this is going to be 7x squared minus 28. And now I want to put these two in so that they combine together through subtraction to get negative 45. Here's another thing that you can do, is if you always put the, if there's going to be a subtraction, exactly one subtraction, and you put it right here, then it avoids being in that third spot where you don't have to take, so you won't have to take out a negative. So I see that I need a negative 49 and a positive 4 to make negative 45. So I'm going to choose to put the negative 49x here and the positive 4x here, so that I don't have to factor a negative out of that second parentheses. All right, so for right now, I'm going to group those two together and those two together. All right, once I do that, I look to see what the common factor is. In this case, it's a 7x. That's going to leave me with an x minus 7. And then I look here to see what's in common. Hopefully you notice that that's a 4. When I divide each term by 4, I get an x minus 7. Right, now I see that I have an x minus 7 in each term. So I'm going to factor out that x minus 7. Just pull that out front through division. So when I go through and I divide this term by x minus 7, I notice that there's a 7x that's left. When I divide this term by x minus 7, there's a plus 4 left. So this would be the factorization. Again, I encourage you to get in the habit, at least for a while until you get more confidence and you're better at these, to just multiply these out to make sure you get back to that. Right? And again, don't automatically assume you're going to. Really be critical as you're doing this to make sure that you're not making any mistakes just because you're anticipating that you're going to get the correct one. Really take your time to do that. All right, I want you to pause the video for just a minute, and I would like you to do this one on your own. Again, what you're looking for is two things that multiply to 5 times 18. I'll tell you that right now is 90, and you want them to subtract to 1. All right, so take a minute to do that and come back, and I will have it worked out so that you can see whether you did it correctly or incorrectly. Okay, let's see how you did. So we're looking for two things that multiply to 90. That's 1 and 90, 2 and 45, 3 and 30. 4 does not go into 90. 5 does go into 90 18 times. Well, we know that from that. 6 goes into 90 15 times. Again, we're looking that it's going to subtract to 1, so we've got to keep going because so far nothing here. 7 does not go into it, 8 does not go into it, 9 goes into it 10 times, and that is it, because 10 minus 9 is 1. Alright, so I'm going to make my rainbow here. We're going to pretend that I made one over top, even though I didn't have enough room. So this is 5p squared. This is minus 18, and I need to use 9 and 10 to subtract to get a negative p. Right, again, that's going to mean that this has to be a negative 10, and again, I'm choosing to put that negative first so I don't have to worry about factoring a negative 1 out of the second parentheses. And this is plus 9p. And again, when I add them up, I get right back to that, which is how I know that that is correct. Alright, I do my grouping. I take out a 5p. I get p minus 2. I do my grouping here. Again, I don't have to put the plus sign in here because this is automatically positive without a sign. I take out a 9. So I get p minus 2. So then I factor out a p minus 2. Oh my goodness. And I get 5p plus 9. All right, so hopefully you got that when you were doing it. All right, I have mine double-sided, so let's flip to the back. And I just want to skip down to one where we have to take out a GCF first. So let's take a look at, let's do 11 and 13, and then I will let you do 15 and 17 on your own. Okay, so in this one, actually I'll do 11, you do 13 on your own, and then you can do 15 and 17 later. So in this, we start looking at it and we say, well, it looks like a harder general trinomial because it's a trinomial and it's got the 3, which makes it harder. But if you pay attention to the general part, you notice that this is actually not a general trinomial. 3 is not double 2. This last term does not have no variable, right? It does have a variable. So we have a GCF that we have to take out here, right? So in this case, it's going to be b. So this polynomial ends up becoming b times 3b squared minus 5b plus 2, right? From here, we're going to factor exactly the same way, all right, the way that you just did, except, again, this b is going to keep traveling down the outside here as you do all your other calculations, all right? I changed my mind again. I want to show you this one also because this has more than just a variable in common. It also has a number. So I want to make sure that you know to look for both of them. So as we look over this, again, this has two of the basic parts for being a harder general trinomial, but not the third. So it's got the trinomial part, it's got the harder part because that's not a 1, but it does not have the pattern of the exponents that we need, right? In fact, we've got this extra b in everyone. The n is fine, n squared and n, this exponent is twice as big as this one, but that b in each of the terms really screws things up. So we're going to take out a 3. Sorry, I didn't say that either. This has a factor of 3 in each of them. In the 30, it's obvious. In the 87, we know that because 8 plus 7 is 15. 3 goes into 15, so 3 goes into 87. So we're going to rewrite this polynomial too as 3b. And then this is going to be 10n squared minus 3 goes into 87 29 times, so this is 29b, and then plus 10. So I'll do this one. I just want you to see that this is how it's got to set up first. But I want to do this one so that you can see that you can't ditch that b. It's very important that it stays with you as you move along. So let's do this. You can do this one on your own. Okay, so here I'm going to say I'm looking for two things that multiply to 6 that add to 5. All right, again, we'll worry about the sign later, but for right now, I need two things that multiply to 6 that add to 5. This one's pretty easy because there's not that many factors of 6. So we've got 1 and 6 and 2 and 3. Be careful, again, make sure that you're saying this right here because otherwise you could comment that actually that these subtract to 5, so that could be confusing. We want to make sure that they add to 5, not subtract to 5. So this is the correct pairing right here. All right, so then I'm going to move this over here, but I'm going to bring this b down, and I want to split this up so that it's the 3b squared, and it's the plus 2 all the way down here. And then I want to write these two in here so that they add to negative 5. All right, so how can I use 3 and 2 to add to negative 5? Well, hopefully you can see that this has to be a negative 3b and a negative 2b. We did not run into that on the front side where both of them were negative, but then again, this is the first one where we've had to add to get that number. Right? So we need to add to get to negative 5. We've got these two. So again, here, we can't avoid having that negative sign in the position between the second and third terms. Regardless of whether we put the 2b here or here, it would still be negative because the 3b is also negative. So I'm going to group these two, and then I'm going to change this to plus a negative and group these two together. Again, I like to have an extra set of parentheses here just to keep that b kind of off to the side so he's just sitting there not doing anything. And then have everything happen inside these parentheses so it doesn't get intermingled with b. At the end, we'll remove this extra set so that the b is just sitting there. All right, so I'm going to take out the common factor of 3b here. I'm left with b minus 1. I'm going to take out a common factor of negative 2 here. And I'm left with b minus 1. Again, I took a negative 2 out. I normally would take a 2 out, but as soon as this is negative, I have to make it a negative that I'm taking out. And again, that's so that these two end up identical. All right, so now I have b, and then the common factor I'm taking out is that the b minus 1. And then what's left of this term is 3b, and what's left of this term is minus 2. Right, now I don't need that extra set of parentheses around that because I'm not going to accidentally think that these two go with this. That is completely separate. All right, so this would be the factorization of it. All right, I'm going to ask you to do this one, but I'm not going to I'm not going to work it out for you because I just changed my battery and notice the one I put in is also almost dead. So I will tell you that the factorization right now for you to work towards is 3b times 2n minus 5 times 5n minus 2. All right, that's what you're working towards. All right, so good luck. Let me know if you have any questions, and I'll see you soon.